In this lesson, we're going to look at proportional graphs and connect them with tables, equations, and situations. By definition, proportional graphs show a constant relationship between two variables. When plotted, they create a straight line that passes through the origin, indicating that the ratio of y to x remains constant. When you make a graph from a table, look for a straight line that goes through the origin, point 0, 0. That's the big clue that the relationship is proportional. Here's the difference. Proportional graphs make a straight line through 0, 0, while non-proportional graphs either curve or start somewhere else. Always check that origin. To find the constant of proportionality, or unit rate, look for how much y changes for every 1 unit of x. That rate is the k in the equation, y equals kx. There are two easy methods to find k. Method 1, use x equals 1. Method 2, use any clear point on the line. Let's take a look at both. In method 1, find the point where x equals 1 on the line. The y value at that point is your constant of proportionality, or k. This method is quick and works great when you can see that point clearly on the graph. If the graph doesn't show what y is when x equals 1 clearly, no problem. Pick any point with clear coordinates on the line, like for this graph, 3, 1 or 9, 3. Then divide y by x. The answer is still k, the constant of proportionality. Every proportional relationship can be written as y equals kx, even a relationship on a graph. To do that, first make sure the line goes through 0, 0 and is straight. Then find k using one of the methods we just learned. And finally, plug it into the equation. To write an equation from a graph, follow these steps. 1. Ensure the graph is a straight line passing through the origin to confirm a proportional relationship. 2. Find the rate, or k, using either the x equals 1 method or the any point on the line method. 3. Write the equation by plugging k into the formula y equals kx. Understanding these steps will help you apply the process to various graphs. When comparing two proportional graphs, both should start at the origin. The steeper the line, the larger the constant of proportionality. Steeper means y increases faster as x increases. Here's a real-world example. Diego and Mia both make bracelets. Diego's line is flatter, which means he earns less per bracelet. Mia's line is steeper, so she earns more money for each bracelet she sells. The point 1k tells you the unit rate. It means that for every 1 unit on the x-axis, there are k units on the y-axis. That's how we interpret the constant of proportionality on a graph. Step 1, look at the point 1k. Step 2, the first number, 1, shows the x value. Step 3, the second number, k, shows the y value. Finally, translate it. K units of y for every 1 unit of x. Here's an example. The point 1, 2 on this graph means 2 miles walked in 1 hour. So the constant proportionality is 2. That's the unit rate, 2 miles per hour. When labeling a graph, ask yourself, which variable do I control and which one depends on it? The variable you control goes on the x-axis. That's the independent variable. The variable that changes as a result goes on the y-axis, the dependent variable. Let's explore how we use a point on a graph to correctly label each axis. Take the example point 2, 8. Here, you earn $12 for every 3 hours of work. This point is crucial because it sits on the line that shows the relationship between hours worked and money earned. Here's how to label a graph using the point 2, 8. The x value 2 signifies hours worked, so we label the x-axis as hours. The y value 8 indicates dollars earned. leading us to label the y-axis as dollars. These labels illustrate the relationship between hours worked and money earned, ensuring accurate interpretation of the graph. Clear labeling is crucial for understanding graphs effectively. Examining a single point on a proportional graph reveals insights about the relationship between x and y. Each point allows you to determine the constant of proportionality, or k, using the formula k equals y divided by x. For example, with the point 39, dividing 9 by 3 shows that k equals 3, indicating y increases 3 times faster than x. This calculation enhances understanding of the graph's behavior. Let's look at what one point on a proportional graph can tell us. It helps us find the constant proportionality, or k. That's the rate that shows how the two values are related. We find it by dividing the y value by the x value. For example, if the point is 2, 8, then k equals 8 divided by 2, or 4. Second, once we know k, we can write the equation of that line from that single point, because every equation for a proportional graph is y equals kx. In this case, the equation would be y equals 4x. Finally, with this equation that came from one point, we can predict other points that fit in the pattern, like 0.52, 416, and 520. They all work because they fit into y equals 4x. Understanding this helps us see patterns on graphs and make predictions, just like in real life situations where one thing always changes at the same rate as another. Thanks for watching, and check out the channel for more videos to build your math skills. Don't forget to like, comment, and subscribe.